And in this video, we're going to be looking at another variation of this intersection problem. So we're going to find out basically intersection of these two arrays that are given to us. Now, if you remember in the last video, we solved a similar kind of problem, but we solved it using set. Now, in the problem statement itself, it was given to us that the results has to be unique, right? So, like, let's say if in this case, if the input was 1, 2, 2, 1, and 2, 2, the result should be just 2. But what if your interviewer, what if when you ask your interviewer question that, hey, the return or the output, can it be unique or it has to be like, it has to appear exactly as many number of times as it's present in as the item present in both arrays. For example, 1, 2, 2, 1 and 2, 2, because 2 appears twice in both arrays, the intersection should be 2, 2. So what if your interviewer says, hey, it has to repeat? Well, in that case, the set approach is not going to work. Okay, so well, that's actually not a problem. Like we can expand upon some of the previous knowledge that we have gained over, like looping over arrays and looking at stuff and working with dictionary combination of dictionary and arrays to come up with the output, right? So we can actually work toward that. But let's ask some more questions to our interviewer. So we're gonna ask, like if the each element in array should appear as many times as it shows in the both array. They say yes, that's why we actually read it here. Now, uh, the result can be in any order. You can ask that question, and they say yes, the result can be in any order. That means, like you don't have to worry about sorting and stuff like that. Um, well, the solution that we're gonna actually come up with, it's not gonna matter, but it's actually good to ask these questions to clarify. So if you're thinking about a different strategy or working on that algorithm that you want to create to solve this problem, it helps by asking these questions. And asking questions actually shows that you're actually trying to get to the root of the problem before jumping straight solving it. So that actually also shows your problem solving skills. So do make sure that you ask questions to your interviewer when you have any, and don't leave anything in your mind, like don't make any assumptions. If you have a question, it doesn't matter how much you think that it's actually not the right question and it gives the interviewer a wrong impression. Don't think about it at all, because they are there to judge your problem solving skills, your collaboration skills. So they should not be judging your attitude towards, like asking questions. And in most of the good tech companies, it's encouraged to ask questions. It doesn't matter how stupid question you think yourself it is. It might not be stupid, it might be enlightening for others to do. So that's the encouragement I'm going to actually give you. And with that said, let's go ahead and move forward and, get to know a little bit more about this problem. So what if the array is sorted? How would you optimize that problem? Well, those could be some follow-up questions. What if the numbers of both arrays are of different size? So, for example, a smaller array is given at the first, and second array is larger. So you cannot assume that the first array that's given to you in the input is always going to be the larger one. Okay, and it actually helps for the time complexity as well. Okay. So with all that in mind, why don't you take the first stab at it and see if you can come up with a potential solution. Um, give yourself a few minutes to think about what the solution could be, or what algorithm that you would try. And I'm gonna pause, or I'm gonna, take a pause for 10 seconds so you can pause the video and then try to come up with your own algorithm. Then come back, unpause the video, and see the solution that we have ready for you here. Okay? All right. Um, so let's go ahead and take a look. Hope you actually had some opportunity to look into or try to take a first stab at the problem. And no worries, don't worry about it. Like, if there's if nothing comes to mind, like, it's always it's always a little bit hard when you're actually ramping up or when you're starting off solving these problems. It's a little bit hard. Soon you're gonna realize that there is a pattern, like, where you have done some problems, and the future problems, you're going to come up with their solution based on the problems that you have solved. So you're going to get to that rhythm pretty soon. So don't don't feel bad. Like, if you have done it, it's a great job. You've actually at least tried it. So let's go ahead and take a look at our solution. Okay. So what we can do is we can now, in the last video I mentioned, like, we're gonna actually build our own intersection mechanism to just to show you, like, how intersection itself works. It's not the exact definition. I mean, I haven't looked at, like, the documentation how set is implemented within Swift language or any other language, but, like, this is a good enough solution for any interview, so that's what we're gonna use. Okay, so the basic idea is to loop over the large array. Okay, and when you're looping over the large array, we're gonna use dictionary to keep a count of number, how many times it appears within that large array. Okay, so we can actually have a dictionary. Dictionary's key is going to be the number that is the current number we are iterating over, and we're gonna have a counter associated with it, which is gonna be the value, and we're gonna increment that counter each time we find that number. Okay, so we're gonna start with one and update it to two, second time when we find three, third time we find it, and so on and so forth. So that is going to be one loop. It's going to help us, like, find out, like, how many times a number is repeated. So how many times a number occurs. So the frequency of the item. Okay. Then you loop over the second array, which is the smaller or same size of array. Okay. Now, once again, this loop is at the same level as the first loop. So the time complexity is not gonna go beyond O of n. It's still gonna stay O of n because you're not nesting your loops. Okay. So in the second loop, what you're gonna do is take a look at each item in the second array and basically uh, try to find that item in dictionary. If you find that item in dictionary, then you simply add that item into the results array. Okay, basically the array that we're going to return as a result. Um, and then you actually decrement the value, the count for that number. Okay, so you're gonna basically decrement it by one, and if the counter reaches zero for that particular number, then you actually just simply remove it by setting it nil. Okay, and you don't do anything for a number that is not present in the dictionary. So remember, in the first loop, if you look at this logic, in the first loop for the larger array, when number was not found in the dictionary, we were adding that number with count as one. In the second array, we're not going to care about it because we just want to count what is common in these two arrays. So we don't care, like, if that number is not added in the dictionary. We don't want to add that. And eventually, at the end, our result array is going to have all the numbers that are common between those two lists. Okay, so that's the approach that we're going to take. Okay, now this is the intersection part. Basically, if you remember in the question, this was like, what if the sizes are different? Now, you always want to loop over the large array first because there's going to be more numbers, so a number can repeat multiple times. So for that, we're going to leverage the fact that we're going to count both arrays and see which one is good, which one is larger, and whichever is larger one, we're going to put that as the first parameter into our intersect. So that's going to be the first one to iterate over, and the smaller array is going to go second. So we're going to simply check if the count is greater, if number first array's count is greater than second array, then we're gonna supply first array as the large array and find intersect function, and second array as the small array. Now, if they are equal, or if the second array is smaller, or like first array is basically smaller than second array, then we're gonna supply second array as the large array, and uh, first array as the small array. Okay, so that actually kind of builds up our logic for that we want to be sure, even if their sizes are different, we still our algorithm still accommodates for those things. Okay, so let's go ahead and open repo and try to write a code and execute some test cases for that. Okay, so first function we're gonna write is going to be intersect. So find intersect. Okay, and we're gonna take large array here. It's gonna be of type int, and small array. It's gonna be of size type int, and we're gonna return an array of integers like that. Okay. Now we're gonna create our dictionary of int, and we're gonna initialize it. So key value pair, both are gonna be int type, and we're gonna have our result, which is gonna be of int type. Now let's loop over first array or large array and see if we have that item in the dictionary. So if it's in the dictionary, uh, then if it's not nil, that means then we want to add, we want to be, if it's in the dictionary, we want to get to that element, um, and we want to add one to its value. Okay, so this is going to increment that counter. Else, we are simply going to say add that item into the dictionary with counter as 1. Okay, so this is going to basically just iterate over and count how many number of times a particular integer appear within that large array. Then we go into the small array and we say if dictionary item. So if you can find a currently iterated over item into the dictionary and that value is not nil, first thing you're going to do is you're going to add that to the result array. Okay, so you're simply going to say, let's add that item. Right now, you also want to decrement that particular item's count, and sorry about that. And a reason you want to do that, because you want to decrement it so you don't count that same item over and over, right? And keep adding it over and over. So in the smaller array, it can appear like, let's say 2 can appear 3 times, but in the original large array, 2 is only gonna appear twice. So you only want to add 2 into your result only twice. Third, it doesn't matter how many times 2 is going to appear in the smaller array. You're trying to find intersect. So uh, the number of times it has appeared in the first array is the number of time that you have to consider adding it into the result array. That's why we are actually going to employ this technique of subtracting the value, and we're going to check immediately after that that if the item that we are the dictionary item that we are iterating over is its value has reached 0, right? If it has reached 0, then we want to actually make that item as nil. Okay, so just discard it. Now this there's not going to be any else because we don't want to do anything with the item that are there in the smaller array. Okay, because I mean if it's in the small, if it's not in the large, it goes out because that's not part of the intersect. Okay, we only want common elements, and then we're gonna simply return our result. All right. With that, our intersect function is ready. So we're simply gonna say enter just any function name, array one, array 2, and we're going to return an array of integer. Okay, now we're simply going to say array 1 dot count is greater than array 2 dot count. In that case, um, when we're going to return basically whatever we get from this function. So large array is going to be array 1, and small array is going to be array 2. And this is going to return a result, so we're immediately going to return back to the caller. Okay, and if that's not the case, else we're simply going to say return find intersect large array, and we're going to make array 2 as a large array, and array 1 as the small array. Okay, now let's go ahead and put some tests. So let's test it out with um, this input. So enter, and we're gonna have 1, 2, 2, 1, straight from the example, and we can run that. Okay, so we have an error. The error is basically somewhere we are, okay, that's just a colon missing. There you go. All right, so, oh, it's not, okay. Um, so Swift optionals, basically, dictionary item can be nil if you're like, the mistake that I made was I was unwrapping that value. I mean that unwrapping gives you the integer, so it's expecting that we are actually extracting the value out of it, which we are not. We're actually just assigning that particular line item or that dictionary item to be nil. Uh, okay. So that's our result, 2 and 2, we got back. Now let's say if I add another 2, what we should get is still 2 and 2. And if we get a 3 here, we should still get 2 and 2 because that's the intersection between these two arrays. Okay, so I hope this gives you a good enough idea. If you talk about time complexity, it's really simple. These statements are going to be executed only once, right? So this is going to be constant time, and all of these are going to be constant time. This is going to be n time, and this is going to be m time. Now, given the m, that m could be smaller, if we consider that n and m both are same, our result is going to be some number. So let's say like we have 6, 5 times constant thing running. So this is like, this is another once, 1. Okay, these are all n. So 1, 2, 3, 4, 5. So our time complexity overall is 5 uh, one time running statement plus n plus m. I mean, there could be like, 3n or 3m, or basically more than 3, 4n and 3m, but it doesn't matter. Like, eventually it's just n plus m. Now, your time complexity can be these two, right? I mean, it can be O of n plus m. And if you give that answer, if you give that time complexity for this particular algorithm is O of n plus m, it is fine. It's not a wrong answer. Mm, I mean, I've seen like, in a lot of interviews where candidates actually think that this is actually wrong. This is not wrong. This value for m and n could be significant. But in cases when n's value is way up, way more than m, then in that case it's just O of n. So we actually consider m plus n is actually same as O of n. So you can actually say O of n, and that is fine too. Basically, your interviewer cannot deny the fact that, like, that it's a O of n or O of n plus n. Both answers are right, okay? Because that's how long the time complexity in general is gonna take for the given input. The output is gonna increase linear fashion. Okay, so I hope that was clear, and you're getting a little bit more hang on how to compute time complexity. So yeah, we're gonna continue this forward until you get, like, um, until you get comfortable computing your own time complexities. So, and I hope you're already out doing that. But yeah, hope you guys enjoyed this another great interview question. I enjoyed this interview question just because it gives you more insight on how the language itself builds these common functionalities. So it gives you the insight on that. Okay, so um, just to get to know, like, what is written behind the API is what comes out with these kind of questions. So hope you guys enjoyed it, and I will see you guys in the next video. Thank you.